Good morning, grade 10. This is Mrs. Pascale. Our last section for this chapter is solving a system of linear and quadratic equations. It's section 9.8. The objective of this section is to solve different types of system consisting of linear and quadratic equations. We can solve a system of quadratic and linear equation by two different methods. The first one is by graphing. It means we need to represent graphically the curve of the quadratic equation and the straight line represented the linear equation. And after graphing it, we can determine the number of solutions, or we can solve it by calculation, and the number of values of x represent the number of solutions. The system of quadratic and linear equation can have two solutions, one solution, or no solution. When we will solve such system, we can find either the first graph where the curve or the straight line cuts the curve at 2 points, and we say that we have two solutions. When the the straight line cuts the curve at 1 point, we say that we have one solution. Or finally, when the straight line is away from the curve, we say that we have no solution. In each of the following examples, we will solve each system by both ways, by graphing first, then by calculation, and for sure, both ways will give us the same solutions. Let's start by example 1. If we need to solve the following system, y equal x squared minus x minus 2 and y equal minus x plus 2. As we learned in previous sections, in order to graph a quadratic expression or function, we need to determine its axis of symmetry, its vertex, determine some points that locate the curve, and finally we draw the curve in the xy plane. In order to graph the linear equation y equal minus x plus 2, we need to take values of points, different values of points for x, replace it in the equation y equal minus x plus 2 to find the corresponding values of y. As the following table will show, when x is 0, y is 2. When x is 1, y is 1. We can take many random points, but for the straight line, it's enough to take only 2 points. By graphing both quadratic and linear equations, we get the following system of xy plane. In this system, we have the straight line cutting the curve at 2 points that represents the solution of the system. The 2 points are defined by the coordinates 2, 0 and -2, 4. So finally, we can say that this system admits two solutions, the points 2, 0 and -2, 4. Let's move to solve this same system by calculation. By solving by calculation, we can find the accurate solutions of this system. Since the solutions of the system represent the points of intersection of both equations, so we need to solve it by taking y equal to y. So x squared minus x minus 2 is equal to minus x plus 2. We need to rearrange the equation to get x squared minus 4 equal to 0. To solve this equation, we can use the discriminant way, or we can use the factorization way. So finally we get x equal to 2 and x equal -2. X equal to 2 represent the abscissa of the first point of intersection. So we need to define its ordinate. We will get the ordinate of 0. So the first point of intersection is 2, 0. And the same for the second point, and we get minus 2, 4. Finally, the systems admits 2, 0 and negative 2, 4 as previously found by graphing. Example 2, to solve the system of equations y equal x squared plus 2 and y equal to 1. As previously said, we need to graph the quadratic function y equal x squared plus 2 by indicating the axis of symmetry and its vertex and taking random points on this graph. Then by graphing the horizontal straight line of equation y equal to 1. This equation represents a special line parallel to the x-axis and passing through the point 0, 1. So, as we will see, by graphing both equations, the two curves does not intersect, so the system admits no solution. As we see, the straight line y equal 1 is below the curve, so there's no points of intersection between the curve and the straight. By solving the same system by calculation, example 3, using solving y equal x squared plus 2x plus 1 and y equal 1. By graphing first, can be solved we need to graph the axis of symmetry, the vertex, the table, and we need to graph y equal to 1.
This equation is in the form
and we
of
get
a square plus b square,
one solution,
so it can
at minus
never
1,
be
0
equal to
as
0.
shown in the following graph.
That's why we say this equation
As we
cannot
see,
be solved
the
or
straight line
admits
y
no
equal
solution.
1 cuts the curve at one point, touches the curve at one point, so we have one solution. To solve this system by calculation, we need to take y equal to y, rearrange the equation, then we get x squared plus 2x plus 1 is equal to 0. Again, we can solve it by factoring or by using the discriminant. So we get x equal negative 1. For x equal negative 1, we can replace the value of x in the first equation of the system or in the second equation of the system, and we get y equal 1. So we have one point of intersection of coordinates minus 1, 1. Please write the previous notes on your copybooks, then solve the following systems by graphing and by calculation. Thank you.